Hello and welcome to the video. In this video, we are going to talk through the idea of linear sequences. And from those linear sequences, we're going to aim to find the nth term formula. So a little bit of algebra formula that is associated with the linear sequence. And then we're going to use that nth term formula to find the 100th term, the 100th number that appears in the linear sequence. Okay, I'm referring to this sequence as a linear sequence because it increases by a consistent amount each time. So a linear sequence increases or decreases by the same number each time. So in this example, I'm adding on 4, adding on 4, adding on 4, adding on 4, and so on. So I know I'm dealing with a linear sequence. Okay, so let's have a go at finding the nth term formula and also the 100th term, the 100th number that would appear in this linear sequence. This is what my working out would look like. To start with, let's have a look at this side of the screen. You can see I've got my sequence here. And in order to find a little bit of algebra, in order to find the nth term formula, the first thing I'm going to do is I'm going to work out what my sequence is going up or down in. So my sequence is going up in 4, up in 4, up in 4, and so on. So because my sequence is increasing by 4, I put a 4 in front of the letter n. N is going to be my variable which stands for the term that I'm trying to find. So whatever the term is that I substitute into here, that's what n will refer to. But I'm not quite finished yet. I also need to go to my first term and do the opposite. So because this sequence is increasing by 4, I'm going to subtract 4, and that's why I land on a -3. That -3 gets placed after the n in my nth term formula. So I now have this little bit of algebra, this formula, 4n minus 3. 4 times n minus 3 would help me find any term in this sequence. Let's try it out. If we look at the number 13, number 13 in this sequence is the 4th term. This is the 4th number in the sequence, the 4th term. So if I substitute 4 as n into this bit of algebra, my result should be 13. So let's try it. 4 times n take away 3. If n is 4, 4 times 4 is 16. Take away 3 is in fact 13. So we know we have our nth term formula correct. So now I'm going to use that nth term formula to find the 100th term in the sequence. So rather than writing the numbers out for 100 terms, I can use my knowledge of algebra and substitution to work out what the 100th term would be. So I know it's 4 times n minus 3 is my formula. So I replace the n with the term I'm trying to find, which in this question is 100. 4 times 100 is 400. Take away the 3 tells me that my 100th term would be 397. So my answers to the original question, my nth term formula is 4n minus 3. That's the formula that's going to help me find any term I wish to know. So I could find the millionth term, I could find the 10th term, I could find the 247th term, as long as I substitute where the n is in this formula. And of course, when I do substitute in 100, my 100th term is 397. Let's have a go at another sequence. Okay, again, we know it's a linear sequence because it's increasing by a consistent amount. This sequence is increasing by 5 each time. So I know I'm dealing with a linear sequence. Let's have a look at my working out. Again, we're going to focus on this process to start with. In order to find my nth term formula, I work out what the sequence is going up or down in. This sequence is going up in 5s each time, so I place a 5 in front of the n. Then I go to my first term and I subtract 5, which is why I've landed on positive 1. That gets wrote after the n in my nth term formula. Just notice that this is a positive 1, not a negative 1. And that's all to do with the number line. If we're on 6 and we subtract 5, we do not go into our negative numbers, which is why we land on a positive 1, which is why we have a plus sign here. If we have a negative sign here, it's because at this point, we've went into our negative numbers. So you just need to think of your number line at this point. Okay, so now I have my nth term formula and I want to find the 100th term. So rather than 5 times n plus 1, I'm going to calculate 5 times 100 plus 1. That's going to give me 501 as my 100th term. So there's my two answers. There's my nth term formula found by following this method. And there's my 100th term found by a little bit of substitution at this point here. Let's have a look at another sequence. So this time the sequence is going downhill. The sequence is getting smaller. I'm taking away 3 each time. But because that subtract 3 is consistent, I'm still dealing with a linear sequence. Let's have a look at my working out. Again, I'm trying to find the nth term formula and the 100th term. So this is how I would find my nth term formula. I look at my sequence. It's going down in 3s each time. So I'm subtracting 3 each time. Take away 3, take away 3, take away 3, which is why I have a minus 3 in front of the n, negative 3n. Then I go to my first term, which is 15, and I do the opposite. So because I'm taking away 3 here, I need to add on 3 here. Again, I'm not landing in my negative numbers, so this is a positive 18, which is why this is a plus sign, and which is why it is plus 18. So my nth term formula in this case is minus 3n plus 18. So if I want to find the 100th term, I'm still going to substitute in. I'm going to substitute in the number 100 as n. So minus 3 times n plus 18 becomes minus 3 times 100, which is negative 300, plus 18, so I come 18 closer to 0, which is minus 282. This is my 100th term. So my answers would look like this. Minus 3n plus 18. Just notice that I could have wrote it in this order, and you may find that in some textbooks or on some worksheets. Basically just putting the minus 3n to the other side of the 18 and writing it like that. Means exactly the same. This and this are equivalent answers, just some people prefer to write their number first and then their coefficient of n second when they're dealing with a negative coefficient. And then my 100th term is minus 282, and again I've worked that out from a bit of accurate substitution. Okay, last example from me before I give you some tasks to work through. If I'm looking at my sequence this time, I'm going up in 7s each time. Add 7, add 7, add 7, add 7. So I know I'm dealing with a linear sequence. I'm increasing in a consistent amount. Here's my working out to find my nth term formula. I'm adding on 7 each time, which is why I'm dealing with 7n. If I go to negative 10, I'm already in my negative numbers, and I'm going to take away another 7, which is why I get even more negative and land on negative 17, which is why I have a take away 17 here. There's my nth term formula. There's the bit of algebra associated with this sequence. Then I use that bit of algebra to find the 100th term. 7 times n minus 17 becomes 7 times 100 take away 17. 700 take away 17, 683 would be my 100th term. So there's my two answers. My nth term formula, 7n minus 17, and my 100th term of this sequence, using a bit of algebra and substitution, would be 683. Okay, so now it's your turn to have a go at a few tasks. The first task is on the screen. What you have here is you have 6 linear sequences and you have 6 nth term formulas, 6 bits of algebra that are associated with the linear sequences on the left-hand side of the screen. What I would like you to do is match up the sequence to its nth term formula. However, one of the sequences and one of the formulas do not match up. That will be our odd one out. So could you pause the video at this point and could you match up your linear sequences to the nth term formula? Okay, welcome back. I'll just go ahead and show you my solution to the first task. So our solution should look something like this. So I'll just talk through one or two of the questions. If I look at the top one here, we're going up in 4s each time, which gives me 4n. If I was to go to my first term and subtract 4, I'd land on -2. So that one matches up with 4n minus 2. If I was to look at this one, which I've highlighted in red, this is going to be my odd one out because it does not match up to 3n minus 3. This minus 3 should be a positive 3. Let's have a look. Because my sequence is going up in 3s, I'm dealing with a 3n. And if I go to my 6 and subtract 3, I do not go into my negative numbers, so I land on a positive 3, which makes this positive 3. So this and this are our odd one out. All of the others should match up, as you can see on the screen. Your second task is very similar to the task we just did on the previous slides. Again, I would like you to look at the 6 linear sequences on the left-hand side of the screen, and I would like you to match them up to their 100th term on the right side of the screen. Just like on the previous slides, one of the matchings is an odd one out. You need to identify and highlight the odd one out. For this question, I would like you to show me all of your working out. So I would like you to show me your full method, how you got from the original linear sequence to find the nth term formula, how you used that nth term formula, and a bit of substitution to obtain your 100th term. So could you please match up your linear sequences to the 100th terms on the right side of the screen? Could you pause the video now and have a go at this task? Okay, welcome back. I will talk you through my matchings. They should look something like this. So let's have a little look at a few of the questions. If we look at the top one, we can see that the sequence is going up in 3. So I'm adding 3, adding 3, adding 3. So I know it's going to be 3n. If I went to my first number and subtracted 3, I would actually land on 0. So I could have wrote this as 3n plus 0, but of course the plus 0 is not needed. When I substitute 100 into this, 3 times 100 gives me 300. Let's also have a little look at this one here. It's consistently going down by -2, so we're subtracting 2 each time, which gives me -2n. Then I go to my first term and do the opposite. So if I add 2 on, I would land on 12. It's a positive 12 because I'm not into my negative numbers. So -2n plus 12. Remember, you may have wrote that as 12 minus 2n, but it would mean the same. So now if I substitute 100 into this formula, -2 times 100 is -200. Then I'm going to add on 12. It's going to take me to -188 because I come 12 closer to 0. If we look at the odd one out, the one I've highlighted in red at the bottom of the screen, again, the sequence is reducing by 2 each time. I'm taking away 2 each time, which gives me this minus 2n. Then if I go to my first term and add 2 on, that's where I get my positive 16 from. If I substitute in 100, minus 2 times 100 is negative 200, and then I'm adding 16 on. So I'm coming 16 closer to 0. So your 100th term should have been minus 184. I use this number here as it's a very common error, a very common misconception. When you're adding on 16 to a negative number, you're coming 16 closer to 0. You're not becoming more negative. So this would be an incorrect answer. Very well done if you were able to match those up and identify the odd one out. Okay, so this is your main task and your last activity. What I've put on the screen here is a lot of information. I've got 8 linear sequences. I've got 8 nth terms. I've got 8 50th terms. I've got 8 images that are associated with these sequences. And I've also got 8 next term rules. The next term rule is simply, what are you doing to find the next term from the term you already know? So we've been doing that a lot during this lesson, simply finding what you need to do to one number to find the next term. We'll refer to that as the next term rule. So what I would like you to do is draw out this table. So you've got 4 columns, and we're going to have a title of sequence. That's going to be in your first column. Then you're going to find the image that is a representation of the sequence, and that's going to go into this column. Then you're going to find the next term rule. So remember, that's just your basic rule. What are you doing to find the next term in the linear sequence? Are you adding on 2 or taking away 3 or adding on 4? The nth term rule will be your bit of algebra. For example, 4n plus 2 would be an nth term rule. And this time we're going to substitute in the number 50. So in most of the tasks on this video, we have been finding the 100th term. So we've been substituting in 100. But for this task, I would like you to find the 50th term. So once you have drawn out this table with the 5 columns and wrote in your 5 headings, I would like you to go back to this set of information, and I would like you to unjumble all of this information. So each sequence should match up to an nth term formula, to a 50th term, to an image of matchsticks, and also to a next term rule. But all the information is mixed up. I would like you to put it in the correct order and place it neatly and accurately into this table. So if we go back to the previous slide, you may want to pause the video here as you fill in your table, making sure that all the mixed up information is put into the table in the correct order. Could you pause the video now, please? Okay, welcome back. I'll just talk through one of the matchings and we'll go for this one here. 1, 5, 9, 13. That's increasing by 4 each time. And if I went to my first number and subtracted 4, I would land on negative 3. So my nth term formula for this sequence is 4n minus 3. Because I'm going up consistently in 4s, my next term rule is simply plus 4. If I substituted 50 into this bit of algebra, 4 times 50 is 200. Take away 3 takes me to 197. So this would be my 50th term. And if I wanted to find a pictorial representation of this image, I'm just looking for the image which has 1 matchstick, followed by 5 matchsticks, followed by 9 matchsticks. So if I was to have a look here, I can see this image, 1, then 5, then 9, and if I was to see the next image in this sequence, it would contain 13 matchsticks. So those 5 would be put together in a row in the table here. For all of the others, you can mark and assess your own work, because if your answer is on the screen now and you've matched them up and all the bits of information have matched up correctly, then we can assume you've completed the task correctly and accurately. Okay, very well done if you did complete that table, and very well done if you had a go at the tasks earlier in the video and were able to do them successfully. You've shown a very good understanding of dealing with linear sequences.